Okay, so let's begin with pandas. So one thing to note that pandas has uh, two main objects or d types or something like that. So what is that? So in pandas, a column is called as pandas series, and entire table is called as pandas data frame, and I will come to that within few minutes. So so let's begin. So here is how we define pandas data frame. There are many ways you can define a pandas data frame. Pandas data frame can be made from Excel, pandas data frame can be made from CSV, all types of those files, as well as from the dictionary, from the string, from a list of lists. There are many different ways from where you can create a data frame. And once a pandas data frame is created, every operation that pandas has defined is applicable to that data frame. So there is only one thing that is stopping you, is that you have to convert everything into pandas data frame, and everything else remains the same. Every other operations and everything remains the same if you are able to translate your data into a pandas data frame. And there are different ways, and right now I have defined a dictionary. You can also create a pandas data frame from a JSON object as well. Means there is n number of things. It is very rare that you are not able to transform your data set into a pandas data frame, and in that case you might use JSON library, or maybe that sort of library that helps you to transform any objects within pandas data frame. So there was an instance where uh, Excel binary files was the data within, and our task was to means able to read that in pandas, and pandas does not support direct reading of binary files. So then there was a third party library that we have to take hold of, and then read that data within that library, and then that data is to be exported as an JSON or maybe dictionary format, and then pandas was used to read that data from. So there are different pipelines that you have to build on when it comes to means normalize everything within the pandas, if you really want to use or take advantage of pandas. Else you, if you are able to manage everything without pandas, you can do, you feel free to do that. But in this case, because we are studying pandas and all that, I'm just giving you an example how I have defined a data frame with the list, with the dictionary. So here is a dictionary. I will just tell you how dictionary is performed, means how it is defined. So here are two key and value. One key tells means the key name is car, and the value is a list, and it holds all different car manufacturer. Whereas the second key tells speed, and it holds same list, and it tells you what speeds are associated to that car manufacturer. So this is a random dummy data which I have created for this tutorial purpose, and this is how data frame is defined. So pd.data frame, so pandas dot data frame in short. So what it tells to pandas is that we are using or creating a data frame with this sort of data. So in this case I will show you, what all other parameters you can pass in here. So data by default is first parameter, indexes and all that. Means if you want to define a different sort of index for any data frame, you can define it through here. Columns, the names, you what you want to define, names, the d types and all that. So you can customize your data whenever you are reading it. And here you can pass in like iteratable dictionary or data frame itself. Dictionary can contain series, array, constants, and so on and so forth. And there are some different changes according to the versions of pandas you are using. So keep eye on it. It's very rare that you will get an error or something like that, but you should always try to update your code according to the new libraries that are coming out, new updates that are coming out. So as I told you, you can create a data frame through maybe a clipboard as well, like you can see over here, read clipboard. So we will get to that later on. Right now we'll just focus on what you can do with the pandas itself. So I have created an object. So pandas data frame is an object of type, I will show you. So it is an object of pandas core frame and data frame, and this is what it is. Now I will show you the type of this car. Car is one column out of this data frame, and so it is pandas series. Oh, my typos. One more. So it tells you that pandas course, and it is a series. Series is just like an array, but in this series you can hold anything, just like Python list. There might be some confusion, and it is okay to be confused right now, but over the time you will understand what is what and what to use, where to use. So you can see it is object. Object means you cannot classify this particular thing within integer, base 16, date time, or other predefined data types. So then pandas itself defines it as an object. Means it is a data type wherein any kind of data can be stored. So by default here you have strings. So all the string and other mixed data types are defined as an object. So maybe one particular cell has integer value within itself, but when you look at the series, it defines itself as an object. So for panda series, this car named column is object, right? So this way you can print out the columns. You can pass in list of list to print out different columns whenever you want. So now I have passed two columns. You get two columns over here, and by default it is defined with two columns, but the sequence changed according to the columns you passed here. So this way you can print out the data frames. So actually this is a subset from the main data frame itself. Here, if you define a data frame with 1000 columns and you call over here only two columns, so this particular object is subset of a main data frame which is defined with 100 columns, right? So this is to be noted that whenever you are filtering things, this is one way of filtering a data frame. So whatever the output of filtered object is always a subset of the primary or the base data frame, right? So as we have seen here, you can define a data frame here. So in this case, if you print data frame itself, it will render out all the columns and all the rows. But if you want to just see how the data looks, it means how and what is the data all about, you can just print df.head. So what df.head tells you that it will print a top 100 rows or 500 rows depending on the parameter you pass. If I pass 2, then it will just give me the 2 rows, and if I don't pass anything, it will just give you default top 5 rows. So this is the default value for df.head. If you don't pass, it is still default 5. And this is about the top 5. What about if you want to see the last five rows, or maybe whatever the number of rows you want to see? So this way you can just pass in tail named parameter, and if you want to see last 2 rows, so you can see with this particular way of definition. So here you can see index 2 and 3 are last 2 rows out of these 4 rows, right? So this is how the data frame tail and data frame head works. So as I mentioned earlier, you can see all the functions and parameters hitting tab button when your data frame is defined, whenever your variable is defined, right? So your data frame has these all parameters that you can use and utilize it. So what is an n? So for example, what is an n? It will tell you the number of it will tell you wherever you have a null value within your data frame. For example, if I have defined here with np.nan and executed this table, so here you can see it is a nan value, means null value, or there is nothing in that value. So np.nan tells it is a null value, it is defined here in that way. None also tells you same thing, none, np.nan, and other various forms of things that you can use to define none value or nan value. So, and here you can see that this value is true. It means speeds column with 0 index has a true value of nan. So it is telling you that yeah, there is a null value within your data frame. So in that way there are many different things. So is null, is nan yields the same result. Maybe there is minute differences between it, but I don't recall any of those. Is none, is null can be used alternatively. So now, as I mentioned earlier, how this filtering works, right? So here we are trying to see trying to filter things out, right? So consider you want to print you want to get the data of only those cars or those manufacturers whose speed is under 300, right? So this is how we have to, means this is how you can get uh, specific data or filtered data. I will just explain you what I'm trying to do over here. So first parameter is data frame. Okay, you're passing data frame, and within that data frame, within this data frame, you're calling data frame itself. It's like you are referring to that same thing, and there you are using a condition. So this condition tells that the speed should be less than 300, right? So whatever the columns where you get the speed less than 300, those indexes in the sense 0 1 2 3 4 is indexes for this particular data frame. So those indexes is returned, right? And it will pass those indexes to this data frame, and within this square bracket those indexes will be printed. So I can show you this example, what you get out of what you get to this output. So you get the indexes which satisfy this condition. So index 2 and 3 satisfies this equation. So if you pass in here indexes, I guess this should work. 1 comma 2 and then list no. So, okay, so there so here you can see that this is the indexes, those are true and false. So pandas understands this internally and returns those indexes whose data frame, okay, my bad, yeah, those indexes matches or satisfies this condition, right? This way you can filter out anything. There can be multiple conditions as well, like this is single condition and I want to use other condition which tells speed should be greater than 100 or maybe 260. So in this case you would only find this data as an output, which is exactly correct, or maybe or condition which tells you either this or that. So in that case you get three of the entries. So one of the condition is that it should be whether less than 300, and other tells you it should be greater than 260. So this 390 is all obviously greater than 360. So that is the reason why you find out there that value, and one of the data is nan. So that is the reason why you are able to get, we are able to getting one entry. So after defining it properly, you will be able to see all rows because it should be satisfying with all rows. That is the reason why we got here all rows, because this data set satisfy these two conditions. So in SQL we put where conditions where this is equal to that and that all, So if someone is from the background of SQL, you can just interpret this thing in that manner, right? So what if you want to manipulate or add or delete some columns within a data frame? So this is the way we define. So I'll just give an example. So you can pass in whatever the name of the column you want uh, within this bracket, or you can call the existing column name as well. There is no point, means there is no restrictions over there. And whatever you pass here should match the length of the data frame. If your data frame has 100 rows and you're passing 50 rows, then it will yield an error. So for example, I'll show you. So it will say that the data frame does not match the length, which is absolutely correct. So we have to keep, means we have to keep the fact that everything should match the number of uh, columns. It won't, how come your data frame will understand that, yeah, you have 10 rows and you have 5 values? How you will map that 5 values to that 10 rows? You need 10 values at least. So that is the reason why it gives an error. So as I mentioned earlier, you can pass whatever the columns name you want, and you can assign anything. So in this case, it is an NP array. You can just pass in the list and it will also assign things itself. Okay, and I'll show you the data frame. So I have executed cost earlier, and I have executed cost underscore 2. So you can see that both of those columns were added. And guess what? If I assign everything to that same column with different values, you will able to find the difference. That same column is replaced with this data. The cost 2 is replaced with 45 with 4 and 34 with 4, because we have manipulated with the data frame. So this way you can create a data frame, right, and add columns and delete column, means manipulate the columns accordingly. What if you want to change a particular cell, right? Then you can call, there are not just two methods, there are many methods that you can use or utilize to your advantage. And here in this case, I'm showing you the two examples, two different ways to manipulate the data frame or the cell values. Okay, so I'm telling data frame to look within data frame where, means at index 2. Index 2 means the row number 2, which index is 2, and column cost, and change that value to 10. So whatever the existing value is, it will change it to 10. So what is our existing value here at number 2 is 264, 267. So once I execute it and look at data frame, it won't change, because no, it has actually changed. Yeah. So you are manipulating data frame with this. So it is cost, not speed. Yeah. Let's bring that cell again, because this way you would be get a reference of how to filter out things, right? So here is what the actual data frame now looks like. Here is a value that is been modified. Now we will just change the speed column to something different, right? So yeah, these all things are case sensitive. If you just pass something else, then it will render some other values, right, or yield an error. So here it changed the value for column speed at location 2, means at index 2. So this is 120. So this way you can manipulate the data frame. This works with loc as well. So I'll just change this value, and as I told earlier, it replaces the value or reassigns the value. So the existing value would be overwritten in the case of assigning the columns as well as the values here. So now I have changed from 120 to 132, and we have to just verify that. and you can see that value is 132, right? And so earlier on I have told you what data frame and what filtering is. So this is advanced version, or maybe a different method wherein you want to get all those values wherein the type of the vehicle matches some certain string, right? For example, in this case, I want all those rows whose all those cars whose type is diesel. So these all rows are, or these two cars are of type diesel, right? You can pass in all the rows, all the cost whose value is 34 or 24. 34 is there. That is the reason why, yeah. So this is how you can get the value 34, right? And if let's say you want to find out the values who, or the type wherein there are two types, means there is a list you are trying to look into, means anything that matches within this list you want that as an output, filtered as an output. So you can just pass in this way. So what it is like, you are just calling a data frame, you're calling a condition, and within that condition you're trying to tell you that tell pandas is that look for the type column, look for the column type, and if wherever this condition matches, means wherever this condition is true, give me those indexes and print those indexes out of this bit, a big larger data frame, right? So I will just show you what is output of this condition. So it will tell that three columns are true and one is false. So accordingly, the first three columns are those three columns, those three rows, which matches or satisfies this condition, and that is the reason why you are able to see this output. In short, what we have done is like match anything that matches within this list. You show me that as an output, or filter that as an output. So this way you can create a subset with a condition or query. Like in SQL also you use in condition or in, and those are values you pass. There you have different syntax, here we have list. So it's too long session right now but if you feel like you want a break or something, you can pause this particular tutorial and have a break, or maybe just get refreshed. And it's on you how you would like to approach to this particular tutorial. But yeah, let's continue further and let's see how to calculate or manipulate a columns within a data frame. Like right now, till now we have seen how we can assign different columns to a data frame, means adding a new column. But what you want to create a new column based on two parameters, or based on a calculation of within those values, or maybe a calculation of something else. It's just a random thing you want to do, and you want to create a new column, or in data science field you call it as an feature engineering, wherein you perform some actions based on existing data, and you engineering a feature. I mean, it's like calculating and creating a different column itself. So for example, in this case, I want to calculate a speed to cost ratio, means uh, how much speed it generates to what cost it cost, right? To the cost. So it's nothing but you just pass a data frame column, that is the data frame series, right, to a data frame series. So and this operation is dividing because the ratios are calculated accordingly. So I'm just performing this simple action or this simple operation over here, which just gives me, if I execute this over here, it will give me an output of series, right? And what we have learned earlier on is like you are creating a series and you are assigning it to this column, speed to cost ratio, right? So in that same manner, I am creating and assigning a series to a column, and that column's name is speed to cost ratio, right? And after this executing, I will just show you how the data frame looks like, and you can see these all same values are populated over here. And one thing to note is that everything will be performed exactly how you're passing the data. because the indexes are stored sequentially like 0 to 1, and indexes for this and indexes for this is same in this case. Maybe if you have two different things or two different data types wherein there are different indexes, so according to the indexes this operation is going to perform, right? And if the indexes does not match, like you are trying to divide 5 rows with 10 columns, 10 rows, it is not possible, it will yield an error, right? So in that case, keep this on your like memory, or maybe keep mind of this thing, that sequence matters a lot. So everything is sequence based. So sequence is nothing but indexes. So in this case, indexes of this both value or series is same. So you will see that same series is mapped over here, right? The same sequence is mapped over here. It is very trivial fact, but you should be aware of these things as well, because there are some instances where you just take everything for granted and then you see the incorrect results and incorrect data types. So this is one of those instances where you should be aware of things. And one more thing, this is too much. Best thing of data pandas is like to grouping things and to grouping things as per you need, right? So group by is just like SQL group by, but with multiple parameters and different things you can perform with group by. So in this case, I'm grouping by. So I will just execute and show you the output, and then I will explain how and what led to this output, right? So this is I'm grouping by type. So actually, what is my output? Means what I really wanted to see. I really wanted to see how different types of fuel perform. Means how not perform, but what is the sum depending on the categories of type. So in this case, diesel has 2 entries, so that is the reason why you can find different values for diesel. But in case there are millions of types and all that, you would find a proper aggregated sum based on category. I will just explain you the output of this particular thing. So you can see diesel type and speed for diesel. So this value is sum of these two. 260 plus 132 is 392, right? Because here are only 2 rows which has same type, you would find aggregation or summation of those 2 rows, this and this. And it yeah, one thing to note here is that the sum operation, you can perform many other operations over here, but this sum operation will perform operations on the data type of certain columns, right? What all the columns you can perform sum on. mm, you cannot perform summation on 2 string, right? You cannot add Tesla and Volvo string together mathematically. Means in normal app string concatenation it is possible, but here you cannot add these two value, you won't get any summed value of these two things. So even if this column is defined, the speed column is defined in string, you won't get output in, means you won't find speed column over here, because it is not a type wherein pandas can perform operations on that. So that thing is to be kept, is like before performing any operations, um, you should be aware of what kind of data type you are handling or working with. Wait a second, typos. Just d types, okay. So I have just printed out all the d types of columns, right? So here you can see speed, cost 2. These columns have integer data type as well as the float for speed to cost ratio. So these 4 columns have data types in numeric columns, right? So those can be aggregated and summed together. That is the reason why you can see those 4 columns over here. So group by, summation, and you can find mean as well. So these are the mean of those categories. So here you can see mean of these 2 rows is nothing but 196, right? Because in this particular case we have only diesel and with two rows, right? Everything else is unique. So if you want to categorize with two or more things, you can do in this fashion. So it's not only to group by with single value or single column. You can pass in multiple columns and you can see how the result perform, means how the result is. So now I am passing two columns within a group by. So first of all it will group by with type, and then it will try to group by with cost. So as you see in here, that group by with type is in this form, and now I will try to put print out the output, which is group, which is the new output according to two columns. So here you can see in diesel we have two different values, right? So that is the reason why you can able to see these two rows. Actually group by works is like finding out the unique and then based on that aggregate or perform those operations, right? So herein you can pass many different operations and you can get many different outputs, and this output is a group by operation, right? You cannot use it as data frame, because dot indexes, data frame indexes is 2. There are two columns as an index. To remove these two columns and create all indexes from scratch, you can use this uh, operation or function. You can call reset index and execute it, and now you can see index is different. You have index 0 1 2 3 4 and group by according to those things. Though this is normal basic pandas. Now we in later on videos I will try to give a comprehensive steps towards like how you can aggregate two data frames together and so and so forth. So this was just basics of how the pandas data frame and operations performed, and how can you manipulate with all these columns and data frame itself. So one thing to keep in mind is like data frame is an object, and data frame has one interlinked object, that is series. Series is nothing but a column, and data frame object is a set of columns and rows. It's just a table in one way or other. And I don't remember or recollect data frame limit. So just search limitations. So there is no specific limitations to data frame, I feel so. Data frame max column or values in column, so forth. But till now there is no limitation from my use case. I have never experienced wherein it tells me that yeah, this is a limit to your columns, you cannot exceed more than this. Actually data frame is very much dynamic, right? It depends on your pandas is very much dynamic. It depends on your system. If your system has a good memory, then it will hold as much data it can. And not only that, there are different variety of things you can tackle this with. The problem with large data, there is an operation called chunk size whenever you are reading things. So what chunk size is telling you that if you have 10 million rows and if you set chunk size to 100, so whenever it is performing any operation, it will perform on that 100 rows first and next 100 rows and so on and so forth. But yeah, with that mechanism you comes, and there are limitations as well, like uh, some operations require everything within your data within your memory, and then only it is able to perform that operations. And in some operation, if you want to find a minimum value, then it is easy to calculate minimum value with the chunk size, because within first 100 rows you will find one minimum value, if and within next 100 rows if you find any minimum value smaller than earlier minimum value, then you will just replace, and so on and so forth. You can able to calculate that minimum value. So practically it is possible to calculate some values and perform some operations with the help of chunk size, but in some cases you really need a good memory, a good system with a good memory, or large memory to be exactly sound. So we have, to recap, I will just tell you what we have seen today. We'll start from NumPy. So we gone through all the basics of NumPy, like what is the minimum, what is the maximum, how to calculate those values, how to define a NumPy array with preset, or a range 0 to 20 for in this case. How can you calculate mean, max, average, standard deviation, percentile, line space. A line space is different concept altogether. A line space is like dividing a range in such a way, like if you want 10 numbers within that range, then it will give you 10 numbers evenly spaced. So that's the way line space worked. And what is shape? Shape is other way to get the size or the dimensions of an array or an object. So in this case, an object array with one dimensional only yields with one value, an object, and so object with two dimensional, you will give you, I guess, where we have executed that reshaped. So it will give you two values, like 4 and 3, in that case 5 and 4. So what is reshape? Reshape is just rearranging a set of array in the format you want, like 5 columns and 4 rows. Sorry, 5 rows and 4 columns in this case. So it will rearrange all the values within this particular pattern. Yes, and one thing to note here is that if your calculation does not match the number of columns, like 5 4s are 20, and if there are not two, there should be exactly 20 elements. If anything above 20 or anything below 20 will give you an error. So that thing is to be kept in mind. What is transpose? Transpose is nothing but just rotating a table. That is the most visual or practical explanation I can give you, but mathematically you're just changing x column, x rows into y axis, just rotating the axis. Mathematically you can say that, converting columns to rows, so on and so forth, or rows to the columns, both will give you the same result. So that way you can convert columns. And what is NP sort? It will sort everything in ascending order, whatever the elements are within those list or array. And then we looked at the concept called appending or extending. I'm calling it appending or extending because you will understand this concept into the later videos, what and why I'm calling it appending and extending. Extending is just because you have seen a series of Python list. You add two lists together, it extends itself, and you can extend a list with list dot extend, then the next list or values of list. So that is the reason why I'm calling it extending. And appending is nothing but you are appending one table over the other. And one more thing to note over here is appending works only when you have same number of columns, right? In extending, the same goes, you need same number of rows, right? So these two things to be kept whenever you're performing these two operations. In this case we were having single dimension, single dimensional array. So that is the reason why we did not got any error while extending, but when appending you will get an error. Like I will show you, it will tell you that both of the axes, the length does not match, because you have defined one with one array with 2 columns and other with 3 columns. That is the reason why it does not able to append together. But what about extending? It will definitely extend itself, because there is only one dimension and it has to keep side by side. So that is the reason why you need to keep eye on the shapes of whatever things you're performing. You can get the shape of data frame as well, and you can see here we have 4 rows and 6 columns, right? So one thing to note, first position tells you the number of rows within your data frame, and the second tells you the number of columns. So we have seen many other operations that can be performed on data frame. What is nan value and how you can get dot minimum value as well, if I recall. Yeah, so it gives you the minimum value, the row with minimum index. I really don't know how this means performs at the back end. I guess it ranks everything based on what? Based on the index, right? I think so. What max gives you? Volvo. Why it gives you Volvo as max? Okay, because Volvo has what? Maximum within itself. No. Okay. df.max gives you the maximum values throughout each and every column. For in this case, 13.2 is maximum speed to cost ratio, and the maximum means if you arrange everything ascendingly, and so comes almost at the end. So that is the reason why Volvo is in this case. And whereas in speed the maximum value in speed column is 390. So this way it tells you the maximum. So there is one more thing that you can experiment with. This exactly this operation I was going to use in the next video, but I will just give a glimpse of it. So what describe does is that it summarizes everything and gives you a table that tells you minimum, maximum, standard deviation, and counts within that particular data frame. So here we have 4 values over here. If within any column there were nan values, then here you could see the count would be less, right? Because nan values are not counted. And minimum value, mean value of these columns. So the mean speed of all these 4 rows is nothing but 283, so and so forth. So this is a summarized view of a data frame, and I will give a proper example of why and how you could use these all operations. So right now it is just an overview of how and what operations you're performing, and I will give a proper workflow whenever you are performing any actions on new data frame wherein you don't know what kind of data frame it is and how it is, means to understand more about data frame or data set in that case. So we will continue that in later chapters. Thank you and bye.